Now the problem we discussed, what is that kth element on sequence or set of n elements, that we discussed already on EREW model and CREW model. Agreed? Yes. Now today we are we'll be discussing finding the kth element on x plus y, where x is a sequence of n elements, say x1, x2, xn, and y is another sequence of n elements. This is for simplicity, we have taken that size is same. Otherwise, you can think about one is of sequence size n, another one is having the sequence of size m. Now x plus y, this plus is a Cartesian sum, so x plus y will give you a matrix of size n square, right? So B is a matrix which I tell x plus yj, xi belongs to x and belongs to y, and for all I and for all j. So this B is an n cross n matrix. B is an n cross n matrix. Agreed or not? Yes? Now I have to find out the kth element from this B. How to find it? Now one way could be that you use your whatever algorithm we have discussed, element for finding the kth element on n, that can be used, right? Here instead of n, you have n square elements. So time complexity would be what? Order. If you use, we have used some algorithm, right? N to the power 1 minus e. Last class you check finding the kth element. Then there is a partitioning element which divides the sequence L. Is not there? Order of n to the power x using order n to the power 1 minus x processor. Like that, is that it? So this algorithm also can be used here to find the kth element, but it has some properties which are not being used to find the kth element if I use this one. Some properties means that xi is added to all y, right? So impact on that row is fixed almost. It is a shift by xi value, right? So that information is not taken into account here, right? So that information, if we can take, then possibly we'll be discussing how we'll be getting the better results. Another thing what we did in this, that instead of using the median element, to partition into, here we took the 3 elements and second largest element, the middle of these 3 elements, we have considered as the partitioning element, and sizes, if you remember, instead of discarding 25%, at least 25% discarding I can do on usual kth element, we will be showing that no, we can discuss more than that if I use the second largest element of the three elements, and by that process you will be reducing your searching area, and it becomes the little faster than the usual thing, but complexity wise it will not change. And this algorithm is on shared memory model with n processors. Now, a little background I want to tell that if what happens, let us assume that X is sorted, or if it is not sorted, you can use your n processor to sort it. Suppose X is not sorted, you can use your n processor to sort it, right? And which it takes order log n time. By the most recent algorithm if I use, then it takes order log n time. Similarly, I sort Y, and using n processor, it takes order log n time. Because that is the cost optimal algorithm we have. So without any loss of generality, we assume that they are sorted. Or if not, you sort it and you get, so X is sorted, Y is also sorted. Right? Now what happens if X and Y are sorted? This is your n cross n element. Now suppose I am interested for finding the minimum element. In that case, it is very simple. This is the minimum element. If I have to find out the largest element, this is the largest element. Agreed? Now if I have to find out the second minimum element is this one of these two. Right? So for in constant time you can find out. In constant time you can find out. This cannot be the second largest element because this gives you the guarantee all these elements will be smaller than this element because X is sorted and Y is sorted. Right? Now suppose I have to find out the third largest element. So which are the probable candidates? This can be a third largest element. This can be a third largest element. Can it be a third largest element? No, right? But this can be a third largest element. This can be a third largest element. So this is your searching zone for third largest element. Agreed? Now in order to find out the fourth largest element, so this can be like this. So in order to find out for small value of k, you don't have to search whole thing. So this is true for kth smallest element or kth largest element. Right? If you are looking for kth smallest element, you will be searching from this side. If you are looking for kth largest, k is very large, n square, nth element maximum, second, third maximum, then you will be searching from this side. Or if you want to do it in reverse, no, I want to do it only for the smallest element. Instead of making that X positive, you negate it. And then you will get, then it becomes the smallest element. Yes or no? If you negate it, then the smallest element becomes the largest element becomes the smallest element. So that can be done easily. So without any loss of generality, you assume that you are looking for the kth element where k is less than equals to n square by 2. K is less than equals to n square by 2. So you are finding the kth smallest element and you have arranged them in increasing order. So you are looking for this upper diagonal part, not the lower one. And also if we have already discussed this part of when k is small, you need constant amount of time to find out the kth smallest element. Yes. Now, what happens if k is not small? How can you do it? But you observe that it has very good properties. These properties, can you make use of it? That is the only thing we are looking for. So let us define BUL is a subpart of the matrix, where U is telling the upper index array, and L is lower index array. What it means that UI this is the ith element, ith row. You have Li and you have UI, right? Array of n elements. So you have in the ith row you have the two index Li and UI, which indicates that in the BUL ith array contains this information, this many elements information. Because this is required because you have to discard some part of the matrix. So the part of the matrix you want to consider under consideration should be defined by these two parameters. Li is the starting index of the ith row and UI is the upper index of the ith row, and you are assuming these elements are under are possible candidates for the kth element. Okay? So in ith row, the number of elements are considered for possible candidate of kth element is UI minus Li plus 1. Agreed? And let us assume that this is Wi, and Wi is the weight assigned to the ith row. Wi is the weight assigned to the ith row, or Wi is the number of elements in the ith row which can be considered as a possible candidate for the kth element. Agreed? Now, n is summation over Wi for all I, which tells the total number of elements which are probable candidates to become the kth element is n. Right? The n is the total number of elements which are the probable candidates for kth element. So n is nothing but the number of elements in BUL. Is it okay? So what we have done, we have defined x, we have defined y, we have defined b, we have defined BUL, we have defined Wi equals to UI minus Li plus 1, and then we have defined n. Now you have a word quantile element of order f. Right? This is a general term you have used in several places in your statistics or some type of course. Right? Yes? No? No? Quantile element? Middle element you know. First quartile you know. Quartile. You have not heard first quartile? You have not used anywhere in your daily life also. Third quartile, first quartile. Huh? First quartile is 25%, right? Third quartile, that in business also you do it. So before that, it is a quantile element. As I told you that what is my target? Target, instead of using the median element, we want to introduce the second largest element, second smallest element of the three elements, and to consider as the partitioning element, right? Which will divide the matrix B into the three parts, less than, equal, and greater than parts, right? And we want to see what should be the value of F, so that you can discard maximum number of elements at each iteration. You understood, right? In the case of median element, we have shown that median element gives you the guarantee that 25% of the total number of elements you will be able to discard at every iteration. Agreed or not? That we discussed. Now what we want to do? No, we don't want to use the median element only. We want to take the three elements and we want to use the middle of these three elements as the partitioning elements to reduce the size of the matrix. This gives you the guarantee 25% because median element is lying there. So 25% is guaranteed, but can we do better than that if I use the second of these three elements? So in order to do that, first let us define what is quantile elements of order F, and then we will define how to go about it. We will discuss those things. Let us assume that you have a sequence of elements AU, AU plus 1, AU, AV in non-decreasing order. Non-decreasing order. Then AR is the quantile element of order F, where R is 1 minus F V plus FU. R is 1 minus F V plus FU, where B is greater than U, greater than equals to U. Suppose F is half. Suppose F is half. What it means? It means the U plus V divided by, that is the middle element. Suppose F is 1 by 4. F is 1 by 4, and U is, suppose for simple, U is say F is 1 by 4, and say U is 1 and V is say 100. So what it means? Huh? F is 1 by 4, so it is 1 by 4, and this is 3 by 4 into 100. Plus 1 by 4 into 1. So what it tells? Let us define in different way. Otherwise, I think that will give you. In that case, F is so 3 by 4 is okay, plus 1 by 4. So in that case, that F is 1 by 4 means it will give you the 1/4 element, first quartile part, right? And F is 3 by 2, it will give you the third quartile thing. So that is the definition of, we are defining the quantile element. Now let Qi be the quantile element for the ith row of the UL. Let Wi be the weight assigned to Qi. You remember Wi is nothing but Ui minus Li plus 1. Then, if Q1 dash, Q2 dash, Qn dash is the sorted sequence of Q1, Q2, Qn with corresponding weights W1 dash, W2 dash, Wn dash. What I am telling that I have sorted, so it is a two tuple, you have Qi, Wi. Now you are sorting them with respect to Qs. So you will be getting Q1 dash, Q2 dash, Qn dash, and correspondingly weight also will be moved W1 dash, W2 dash, Wn dash. Agreed? Is it clear? No. Just I have sorted Q. While I have sorted Q, W is also attached to Q, so W also will change its position. Nothing else. Now Qt dash, then Qt dash is the weighted quantile of order F if if I sum of these weights till t minus 1, if I find that it is less than equals to 1 minus f times of n, but adding the weight of the Qt, it is exceeding 1 minus f into n, then we tell Qt dash is the, let me do this way, less than only. Then Qt dash is known as the weighted quantile of order F. Now you think about this, you have this is Q1 dash, Q2 dash, Qn dash, and weights you have W1 dash, W2 dash, Wn dash. Right? So Qn dash is this one, Q2 dash is also this one, Q3 dash is this one, and Qn dash. This is the of his own row, it is the quantile. Of his own row, it is the quantile. Agreed or not? And if it is the quantile of order F, that gives you the guarantee that there exists there exists there exists f into nth element smaller than this element, not n, f into w1, sorry, f into w1 element smaller than this. Agreed? Now similarly, f into w2 elements will be smaller than, less than or equals to this element, f into w3 elements less than or equals to this elements, and so on. Agreed? Now, suppose this is your qt dash. Suppose this is your qt dash. How many elements will be smaller than qt dash? Guaranteed. This is, you are telling 1 minus f, right? So this is your 1 minus f, this side is f, so you have at least that many elements will be, this is 1 minus f, and this is w, w1, w2, w3, w this, right? So what I am doing here, w1 plus w2 dash, wt dash. w1 dash gives you the guarantee of f times, this gives you the guarantee that f into w1 dash, f into w2 dash, f into wt dash, right? This is f of them, they are less than. This is the sum. Agreed? So this gives you the guarantee that f into, this side is 1 minus f of total n, 1 minus f of total n, so it is 1 minus f into size, right? Agreed or not? So this gives you the guarantee that that size of elements at least less than or equals to this element. Yes? Up to this we have done. Similarly you can see from the bottom side also this part. I have talked about this part, that f into 1 minus f. Similarly you can tell about this part also, right? Because I am assuming that this is the element, so I can tell that f into 1 minus f. This side also you can define similarly. Now let us assume that you have weighted quantile of order f, half and 1 minus f. And S is the second largest element or second smallest element of this. Right? So, for simplicity, we are assuming that BUL is of this structure, and this is your order F, order half. Say, let us name them. First weighted quantile order F. Let it be Q1, Q2, and Q3. Right? Three weighted quantile. One is name is Q1, Q2, and Q3, and S is the second largest element of this. So this is your Q1, this is Q2, and this is your Q3. Is it okay or is it reverse way? This is Q3 or this is Q1? Order F. F is 1 minus F. This should be Q1. This should be Q3. Right? 1 minus F. Now, one of them will be the second largest element. See what happens? Suppose Q2 is the second largest element. It means one of them will be the smallest element. Right? Let us assume that Q2 is the smallest element, second largest element. Q2 is S. If Q2 is S, what is the E1 is the area, or E1 contains the minimum number of elements which are smaller than Q2 and smaller than S, second largest element. And E2 is the number of elements, minimum number of elements which are larger than S. Now, if Q2 is the smallest element, second smallest element, Q2 is the second smallest element, one of them is the smallest element. In that case, suppose we assume that this is the smallest element, then this gives you the guarantee that that many elements will be smaller than S. Because this is the smallest element, right? So, and this is the second one. So, this element will be smaller than this. So, all these elements will be smaller than Q2. Agreed? And similarly, right? This is the largest element, larger than these elements. All these elements are larger than all these elements are larger than these elements. This is guaranteed. All these elements will be larger than these elements, all these elements will be smaller than these elements. This is guaranteed to you. Now, what is the size of this? This is F, this is F, this is half, this is 1 minus F. This is F, this is 1 minus F. Now, the area is this one, that is F into 1 minus F plus 1 by 4 minus half F if Q2 is equal to S. Agreed? Huh?
About elements smaller than Q2. Are they along the half line or along this half?
This line. All these elements will be smaller than this.
Why so? Why not being that?
Which element?
The
Bottom one? That's I don't know. Maybe. But guaranteed. I am telling minimum number of elements. These elements can be smaller than this. So I cannot touch. That is true for any.
Earlier when you took the second largest and third largest, you showed that these elements will be definitely smaller than this.
See, while I am considering the original matrix, I am telling this one. I am telling that these elements and this element smaller than this. I never told that this element is smaller than this. Right? There is no guarantee, because guarantee is this is increasing, but there is no relationship between these two. Agreed? Along the rows, along the columns, relation maintains. But diagonal relation is not there. It is not known. Right? But this cannot be the fourth element, this cannot be the third element, because this 1, 2, 3, at least there exist 3 elements smaller than this. There exist 3 elements smaller than this, so this cannot be a third element. But this can be a third element because this element may be smaller than this element. Right? That is the thing I told. Agreed? So is it okay? This Q1 creation, if Q2 is the smallest, second largest element. Similarly, I can find out this side is f into 1 minus f plus 1 by 4 minus half f if Q2 is. Now, if Q2 is not S, suppose Q2 is the first element or the third element, right? So let us assume that Q1 is the second smallest element and Q2 is the first element, right? In that case, what it becomes? If this is the second element, if Q1 is S, if Q1 is S and Q2 is smallest, in that case, the area is same. Area is same. Agreed? But what about the other side? This is the second one. This is the largest one. What should be the area? Area will be this one. Because this is the largest one. This is the second largest one. So this gives you that this many elements will be larger than this element. So that area is f into 1 minus f into 1 minus f plus half f. Is it half f? This is f, right? And this is 1 minus f, agreed or not? Because this part is f, so this is a 1 minus f. So you got this area is f into 1 minus f. What about this area? This is f and this is also f. So, this is 1 minus twice f into f. Okay. Or I know this much, 1 minus f, 1 minus f minus f. So 1 minus twice f. Yes. Into f. If Q1 is S and Q2 is smallest. On this side it is same. F1 minus F plus 1 by 4 minus 1 by 2. Now if Q3 is the smallest or the second largest element and Q2 is the smallest, then the result is same. So I can write here Q3 is smallest, for this case same. What about here? If Q3 is the second largest element, instead of this is the second largest element and this is the largest element, so result is same. So this is true for Q3 is S also. Now the thing is that Q2 is the largest and Q1 is the second. This is the smallest, this is the second and this is the largest. what happens in that case. If Q1 is second one and Q3 is smallest, what is the value? If this is the second one, this is the smallest, then size is, guarantee part is this much. Agreed? Which is nothing but f into 1 minus f plus 1 minus 2f into f. And this is true for the other case also. Q1, Q3 is second and Q1 is smallest. Agreed? Now what about here? This becomes this one. So this becomes here f into 1 minus f plus 1 by 4 minus half f if Q1, Q3 is S and Q3 is smallest, Q1 is smallest. Right? Now your aim is to maximize these two areas. Maximize U1 and E2. Right? If I can maximize that one, that will give you, so for what value of F you get E1 and E2 maximum, that means U1 and E2 will give you the how many elements you can discard at each iteration. So if I may just simply take d by derivative of this, you will be finding that F is maximum at 1 by, this function E1 and E2 will be maximum when F equals to 1 by 4. E1 and E2 is maximum when F, otherwise if you increase F, you may find E1 is increasing, you will find E2 is decreasing. So that will not help you. You have to optimize in such a way that you get the guaranteed that much discarding part is there. So F is 1 by 4, and if F is 1 by 4, then what is the value of E1? What is the value of E1? And you remember this contains all of them and having one multiplicative factor. What is that? Right? Total size. This is the factor. So total size is there. If F equals to 1 by 4, what happens? The value is what? 1 by 4, 3 by 4, plus 1 by 4 minus 1 by 8. 3 by 16 plus 1 by 4 minus 1 by 8. What is the value? 5 by 16. So you can find out for every value it will become 5 by 16 and 5 by 16. So what it gives you that if I consider the second largest element of these three quartiles, because F is 1 by 4, so it is first quartile, second quartile and third quartile. Out of that, if I use the second largest element or second smallest element to discard it, that gives you the guarantee that at least 5 by 16n elements will be discarded at each iteration. In the initial case, or if I remember the first finding the kth element, it was having that 4 by 16, that is 25%. If you remember, it is 25% you can discard at each iteration. Here, instead of 25%, you discard 5 by 16 elements. Right? So at each iteration, you will be able to discard 5 by 16 elements of B from your possible search zone. Now, if you have n elements and n processing elements, you just sort it and find the kth element, which takes order log n time. That we just sort it. Sorting takes log n time using n processor. So these iterations 5 by 16 n to the power w, it will be iterated till it is greater than n. If it is, I find it is less than equals to n, I stop it. So w is the number of iterations. I will iterate it. Every time it is reducing by 5 by 16 times, right? And till I find it is equals to, less than equals, greater than equals to n, I will continue. So I can find out this iterations also will be what? How many times? So you just take w log of 5 by 16 n is greater than equals to log n. So you can find out what is the value of w, right? W is also a factor of initially capital N is your order k, that I will come later on. So you can find out this iteration will be of the order log k. So I can find out the number of iterations you need to reduce the size of the BUL of the order n, so that you can use the n process to sort these n elements and find the kth element in constant time. Agreed? So next part is that how I can define BUL. I can start with the BUL is your B. But as I discussed with you, that depending upon the value k, BUL can be defined. Because as I told that for smaller value of k, if I should not have defined BUL equals to B, right? So this can be obtained from this one. Suppose you have this and this is your Bij, ijth element of the matrix x plus y. Bij is greater than equals to at least I into j minus 1 elements. This is I, this is j. All these elements will be smaller than this element, right? So the number of elements is I into j minus 1. Agreed? This is given to you. Now, Bij is the kth element. Bij is the kth element. That gives you that exactly k minus 1 element will be equals to I dot minus ij minus 1 elements. Yes? Similarly, this side you have, if it is j, this side is n minus j plus 1, this side n minus I plus 1. So if Bij is the kth element, then exactly this into this, Nij minus this into this, that must be n square minus k, n square minus k. Yes or no? This element is what? Total number of elements? N minus j plus 1. Agreed? Size is also n minus I plus 1. So this area is and this into this n minus I plus 1 and n minus j plus 1. And if it is the kth element, then the total element is n square. So n square minus k will be this size. Yes. Now Bij can be, no, I'm not talking that is the kth element. Bij can be kth element if tell me what? Bij can be the kth element if
less
Less than?
Equal.
Less than equal. This is one condition you can easily obtain, which tells you I is less than equal to k by I, k by k. That is guaranteed. Right? I could have taken upper will not give you the guaranteed thing, the floor gives you the guarantee. Similarly, I can obtain n minus I plus 1 into n minus j plus 1 n square minus k. What should be the symbol here? Greater than equal? Is it greater than equal, I will write? Right? And from there also you will be able to find out a function in terms of j. Yes or no? Just not possible?
N and J. In terms of N and J.
Jn plus I dot j minus plus n minus j plus 1 minus in. This gives you minus k greater than equals to minus in minus j plus ij plus 2n minus I minus j plus 1. This gives you j n minus I plus 1 greater than equals to k minus n plus I plus 2n plus 1. This gives you j greater than equals to k n plus 1 I plus 2n plus 1 n minus I plus 1. So this is after calculation you will be getting this. So if you know this, then I can define your ui is n if I is less than k by n and k by I otherwise. Li is your k minus n plus 1 I plus 2n plus 1 n minus I plus 1 if I is less than equals to k plus 1 and 1 otherwise. Right? Now, you know for different value of I, you can get ui and li now. And for you at this moment is because lot of arithmetic will be coming. So initially we have seen that BUL is order k through some harmonic number. So we have shown that BUL is order k. Right? So if k is very small, BUL size is very small, you just sort it and get it. If k is order n square, then you iterate it, and we have seen that after log k iterations, the size will be order n, and you get it. Right? Now, think about the whole process. How much time you need if you have n process? First, what we have decided that you have x and y, use the sorting algorithms which takes order log n time to sort using n process. Right? Then second step is what? You have to initialize BUL. That initialization BUL, everybody finds his I. It takes constant amount of time. Right? It takes constant amount of time. Right? So initialization BUL takes what? Constant amount of time. Then you have to know what is the value of WI. That takes constant amount of time because every processor finds UI minus Li plus 1. then you need to know what is the value of n, because you have to check whether n is smaller than or equals to small n or not. Agreed? So in order to find out the capital N, you need to know summation over ui minus li plus 1. You have n process, n summation, log n time. Right? Not more than that. Agreed? So you can find out the capital N. Then there is a for loop while capital N is greater than small n, while capital N is greater than small n. Right? You have to find out what? First quartile, second quartile, and third quartile using n processors. Right? Yes? Which is how much time? Log n. Then second largest element is to compare the three elements, get one constant time. Then you divide into the three parts. Right? That element, second largest element, has to be broadcasted to all the processor, which takes log n time. Each processor on his array, you have li, you have ui. He finds out that the number of elements smaller than, greater than, that he is finding. Right? So that is, since it is in sorted order, binary search. Worst case, log n time he needs, because n elements may be there. He finds it in log n time. The number of elements smaller than, number of elements larger than. Right? Now the number of elements smaller than, you have to add them to find out the size. If it is greater than k and other things, you will be assuming that this is the searching zone, otherwise searching zone, otherwise this is the element. Yes. And this takes log n time. Everything can be done log n time. So the time complexity becomes log n into log k. Log k time iterations. Now after that also, if you don't get the kth element, the size is reduced to n, sort it, and log n time, find the kth element. Right. So now can you write your algorithm? Or no, you need, I should write the algorithm. Can you write? Huh? Huh? One is sort x and y in non-decreasing order. Initialize BUL by defining U and L. Get N Y N greater than N. A. Find the second largest element. So this takes order log n time. This takes order log n time. This takes order log k time iterations. Order log n time. Order log n time, because addition is coming into that. This takes order log n time, binary search. This is order log n time. This is constant time. This is order log n time. This is order log n time. So the time complexity is order log k into log n time. Is matrix. Okay. Next class I'll cover matrix and that graph